Okay, this video, YouTube Nation, is also, especially for 6 hour day, because I'm not here. Actually, it's kind of funny 6 hour, because I'm actually standing in front of you right now because I'm starting the video for you, but I won't be here in a little bit. So anyway, this is third hour, recording third hour, and there's some people who. So, Katie, would you like to give a shout out to one of your old friends?
Hi, Rowan. Sorry you're no longer in third hour.
Yeah, we're sorry about that. Yep, Cole.
What's up, Jackson?
Whoa, Jackson. All right, been called out by Cole. Cole misses you. Every once in a while, Cole grabs a Kleenex and sheds a tear in class because he misses you. But we make it through. So yeah, so it's a good time. So 6 hours you're watching this video. If you guys get confused at any point, obviously you can pause it, you can rewind it. You can search a video last year. You can watch it when you get home. But we're going to talk about hyperbolas today. Let's start with this. Hyperbolas are the set of all points whose distance from two foci have a constant difference. Now, do you remember how that's similar or different from yesterday's definition of an ellipse? Yesterday's definition of ellipse said the set of all points whose distance from two foci have a constant sum. They add to the same number. Today, their distance from the two foci have a constant difference, so they subtract to the same number. And I'll show you what that means in a little bit. I put it up on the board over there, but 6 hour won't really be able to see that, so I'm going to put it up on this board and give a better idea. Question, Anna. Test right now we're looking at next week, Monday, but the fact is that it's very possible that we could have a snow day on Thursday. It looks like we're supposed to start getting some freezing rain tomorrow and stuff, so that'll be pushed a day out. I'll try to give you a definite, definitive idea on the study guide tomorrow, okay? You get your third assignment today. We only have a total of 4 assignments. Very possible the test can be pushed to Tuesday, or we'll see where we go, okay? The nice thing is we have more time second semester than we did first semester, so we can work around. What up, Katie? Is this a smiley face test or a frowny face test? That's a good question. It's tough to say. A few years ago, this was a tough test for a lot of the students. The past couple of years, this test has gone really, really, really well. However, does this test have the potential to be disastrous? Really, only if you're a student who's missed school. Okay, so if your student misses a lot of school, it can be really challenging. Okay, I'll get to that too tomorrow. All right, so the equation for hyperbola is very similar to that of an ellipse. X minus h quantity squared over a squared and y minus k quantity squared over b squared equals 1. Now for the ellipse, what went in the middle between the x minus h plus? What do you think goes here? You guys are smart. Geniuses. Okay, so what we're going to talk about right now is the structure of the hyperbola and how to make its general shape. The center, in this case I put it 0, 0, but the center is going to be at HK. And then in order to construct the hyperbola, we start by constructing what I call a ghost box. Okay? And the reason why I call it a ghost box is because it's not actually part of the graph, but we use it in order to construct the graph. The book doesn't teach you to necessarily do this. This is just something that I kind of fiddled around with at some point in my life, and I think it's a good thing to do, okay? We construct this box, and as I'm going to give you some dimensions for the box here in a second, that box will help us kind of generate all the special points that we need. Anybody want to guess how many units in the horizontal direction this box is stretched? A. Whatever A is, that's the number of units that this box is stretched horizontally. Anybody want to guess how many units this box is stretched vertically? b units. That's really similar to kind of how we started with our ellipses, right? Okay. Now, once we have that box, the next thing we can do is draw our asymptotes, and our asymptotes go right through the corners of the box. They're like the diagonals of the box. Now, none of this is the actual graph yet. We're going to sketch a graph in just a second. Okay, this is just how we generate the graph. A hyperbola has one of these two shapes, okay? It either kind of goes like this, or it goes up and down like this, okay? And the question is, which one is it going to do? Okay, in order to help you determine that, I'm going to write the second equation over here. This is going to be y minus k, quantity squared, over a squared, minus x minus h, quantity squared, over b squared, is equal to 1. Can anybody see here what's different about the equation on the left compared to the equation on the right? Yeah, the tops are switched. In here, the x minus h is positive, right? And the y is negative. Here, the y is positive and the x is negative. If the x is positive, then it opens up sideways like this guy. If the y is positive, it opens up vertically like that guy. Okay? So this is going to open up sideways. And so what we can do is right on the sides of the box are what we call the vertices of the hyperbola. And the hyperbola follows those lines and touches at the vertice. And so you get that shape. Kind of cool? No? Okay. All right. Let's make it cool. All right. All right. Thank you, Dylan. Appreciate that. So let's start to lay out these points. The vertices. The vertices are these points right here that we just put down the graph. How many units are the vertices from the center? A units from the center, okay? A units, right? So I move A units horizontally or vertically. So is that going to change the H value or the K value? So therefore, the vertices are located at H plus or minus A, and then K. The transverse axis is really the distance between those two vertices. Anybody want to take a guess at what the distance between the two vertices is? 2a. The asymptotes, here's where you got to dig a little bit deep, folks. The asymptotes are imaginary lines, correct? So I'm going to write an equation for the asymptotes. In order to write an equation for a line, I need slope and I need point on the line. What part of the graph do the lines go through? They both go through the center, right? In this case, it looks like it's 0, 0, but they both go through the center. What's the center of the graph? HK. So that's the point on the line. Now let's think about the slope. One of the lines has a positive slope. One of the lines has a negative slope. We can figure out the slope by looking at the box. What's the rise of the box? What's the run of the box? So therefore, the slope is plus or minus b over a. So if we take our equation for our line, which is y minus y1 is equal to m times x minus x1, we can write the equation for the asymptote by simply using point-slope form. It will be y minus, what is my y1 value? K equals, what's m? Times x minus, what is x1? H. And that is then the equation for our asymptotes. Looks pretty involved, huh? Now, I will not make you put it in slope-intercept form because we have the plus or minus b over a, so you can just leave it like that. Foci, 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 foci. Here they are. You have focus point 1, focus point 2, foci is the plural. They sit kind of on the inside of the hyperbola, like the focus point sat on the inside for the parabola, okay? And so those focus points that are sitting there, anybody want to take a guess how many units from the center those foci sit? C. Remember yesterday? We had to find C, right? For ellipses. What was our formula to find C yesterday for the ellipses? A squared minus b squared was c squared. Today, it switches to a squared plus b squared is c squared. The Pythagorean theorem is the formula that we use in order to find C. It doesn't matter if a is bigger or smaller because they sum, and so you can't come up with a negative. Okay? It's all right. It's confusing stuff, right? Like, I get it. I get it. We're going to take some time to figure it out. All right, so C units from the center, is that going to change the H value or the K value? So it's going to be H plus or minus C, and then K will be the location of your foci. Really good job. We're only going to do 2 examples today because I think that that's really all that you'll need. And we're going to start by doing this example 1, okay? And we are going to list all these important points. We're going to start with the center. We're going to talk about the vertices. We're going to talk about the length of the transverse axis, the asymptotes, and the foci. And we're going to sketch a graph. Okay. So, since we're only doing 2 examples, make sure you really dig deep and focus on these. Okay? Take a big breath and we focus in. Whew. Here we go. The center. Where is the center of this graph? 0, 0. Very good. What would be a common response other than 0, 0? What might somebody say? Yeah, 2, 5, but that's how we stretch the box, right? Okay. The center is 0, 0 because there's nothing inside the x or the y or the squared part. Okay, so very good. We got 0, 0. I'm going to make my box, the ghost box, right away. It's perfect. It helps me out. How many units do I stretch the box in the x direction? 2. How about the y direction? 5. So if I go over 2 in each direction, I go up 5. Got my ghost box. Once I have that box, sketching the rest of the graph is super easy. I draw my asymptotes through the diagonals of the box. And now it's time to draw my hyperbola. Does the hyperbola open side to side or up and down? Why does it open side to side? Because the x is positive. Now, this is the big difference from yesterday. When I constructed this problem for us to do, I put the 25 under the y. And I figured if I did that, some people would say that it would open up and down. Because if it was an ellipse, we would say that it was kind of an ellipse that was stretched vertically, right? It's different with a hyperbola. You can see that the box is stretched vertically, but the hyperbola opens up side to side because the x is positive. Everybody see that? That's critical. So therefore, my vertices go on the side of the box. And then my hyperbola just follows those asymptotes. So a very wide opening hyperbola. Okay. Everybody good with that? All right. So I've sketched the entire graph. Now it's just time to name these things. The location of the vertices, what are they? Yeah, 2, 0, and negative 2, 0. So you could write it as plus or minus 2, 0 if you want. The length of the transverse axis, that's the distance between the two vertices. Very good, it is 4. Or, we're doing this pretty quick, aren't we? The asymptotes, we need two things. We need a slope, and we need point on the line. What's the point on the line? What do they both go through? 0, 0. And the slope is going to be rise over run. 5 over 2, because the rise of the box was 5 and the run of the box was 2. So you know that box is helpful? Yeah. Foci, oh, okay, so the asymptotes then, so I've got those pieces. Move the foci down here a little bit. So I've got y minus y1 is equal to m times x minus x1. Now, I'm not going to make you put it in slope-intercept form, but when you got a 0, I mean, just get rid of the 0 for crying out loud, right? I mean, so this ends up being y is equal to plus or minus 5 halves times x. That does happen to be slope-intercept form. But if you got a 0, get rid of the 0 at least. We good? Okay, foci. How do I find the foci? A squared plus b squared is c squared. Now, you guys, I want to be clear to you. Technically, in this problem, a squared is 4, but it doesn't matter, does it? Either way, you come up with c squared is 29. So therefore, c is equal to the root of 29, which is if you were to estimate the square root of 29, what would you estimate it as? Wow. Okay. So dy only just said 5.23 is estimating this at. Let's see how close he is. I would just go for 5.5, but let's just go for so square root of 29, and we get 5.4. So all right. So whatever. Good job. So about 5.4. So I'm going to go 5.4 units from the center. 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5.4. So those are my focus points. So what's the location, the focus points then? Plus or minus the root of 29, 0, right? Sure, that's fine. If you like to write it as decimal, it's fine. 5.38, 5.4. You good? Okay, now I just want to show you how the definition of the ellipse checks in here. Here's the definition of the ellipse, okay? What I do is I go ahead and I take my marker, okay, and I pick a point, the definition of a hyperbola, excuse me. I pick a point there. And if I look at the distance that point is from the two foci, you can see I have, say, D1 and D2, okay? I'm going to pick another point. I'm going to pick a point right here, okay? And we're going to say that that is a distance from the foci as well. And we're going to call that D3 and D4, okay? Here's what we know. If you take D2 minus D1, and if you take D3 minus D4, you come up with the same difference. Those would be the exact same. That's technically how a hyperbola is generated. Now, did we have to actually do that in order to construct it from the beginning? No. But that's the definition. I want you guys to understand where it comes from. My teacher in high school, when he went over hyperbolas again, when I saw it the second time, then he actually generated the formulas for us, which we just don't have time to do, so we're just going to leave that aside. Flip it over to the back side. Oh, whoops, sorry. Let's do this side, and then we'll do the one on the back. Just those two examples, okay? All right, so now we're going to flip it, so it's going to open up vertically, okay? So let's get some things written down here. We've got HK as our center. I'm going to draw my ghost box. How many units am I going to go in the y direction for my ghost box? A, so I'm going to go up A units. And how many units am I going to go horizontally for my ghost box? B units. So I go A units up. I go B units over. I draw my asymptotes right through the diagonals. Will this hyperbola go up and down, or will it go side to side? Up and down. How come? Because the y is positive. Okay? So I put my vertices this time on the top and the bottom of the box. They spread out along those asymptotes. And I have my graph for my hyperbola. How many units do those vertices sit from the center? A units from the center, right? So, Kevin, you're absolutely right. It's 2A units between the vertices. Each one is moved A units from the center. So will that change the H value or the K value? So therefore, the location is H and then K plus or minus A. The length of the transverse axis, that's the distance between those two. 2A. Asymptotes. I need a point on the line, and I need the slope. What's the point on the line? HK. What is the slope? What's my rise in this case? A. What's the run? So plus or minus A over B, right? So we can see the equation for the line is y minus k equals plus or minus A over B times x minus h. The foci do sit on the inside of the hyperbola in its opening, so they are moved vertically this time. Any guess how many units from the center they are? They are C units from the center. That will change the y value. So the location is H, and K plus or minus C is the location of your foci. Got it? Okay, so we've seen the general structure. We've seen one example. Let's do one more where it's shifted. Flip over the back side. We're going to do letter B. Forget about letter A. What do I have to do before I start this problem? Divide by 36. Very good. If I divide by 36, I get y plus 2 quantity squared over 36 minus x minus 1 quantity squared over 4 is equal to 1. I need my important characteristics. It starts off with the center, the vertices, length of the transverse axis, asymptotes, and foci. Center. Okay, 6th hour, I'm hearing a lot of stuff in my 3rd hour. A lot of them are saying -2, 1. Some said 1, -2. A lot of them said 2, -1, or -2, 1, but switched it to 1, -2. Again, the horizontal shift is 1, and the vertical shift is 2 to the left, so -2. Same thing. Okay, so when I make my center 1, -2, and then I go to make my box, my ghost box, how many units will I move in the y direction? 6. So it looks like 6, -2, so I would have to go all the way down to -8, huh? So it looks like if I make a 10 by 10 graph, hopefully that'll be enough. Okay, so we're going to do 10 by 10 graph here. Cool. All right, let's start to graph this guy. So I plot my center, 1, -2, so over 1 and down 2. Okay, I'm going to make my ghost box. How far up and down do I move? A total of 6, so that will bring me up to what? Up to 4. So 1, 2, 3, 4, 5, 6, so all the way up here to 4. All the way down to, yep, 4, 5, 6, 7, 8, down to -8. And then how far to the side will I move? 2 each way, right? So 1, 2, so over to 3, and then 2 the other way, so I'll be back to -1. And you can start to, you know, sketch that box then. I've got it. Okay, I'm going to draw my asymptotes. Okay, is this hyperbola going to sit on the sides or the top and bottom? Why is it going to sit on the top and bottom dy line? Because y is positive, so it's going to sit on the top and bottom. So my vertice is going to be here, and it's going to fall off towards the asymptotes. Vertice down here, fall off towards the asymptotes. And there's the structure of my hyperbola. What? So what's the location of the vertices? 1, 4, and 1, -8, right? Over 1, up 4, and over 1, down 8. Length of the transverse axis, that's the distance between the two. 12. Asymptotes, I need slope, and I need a point on the line. What's the point on the line? 1, -2. It's the center. What is the slope? What's my rise for the box? My rise for the box is 6. What's my run for the box? 2. So 6 over 2 is 3. So plus or minus 3 is the slope. So I get y minus y sub 1, which would be y plus 2 was plus or minus 3 times x minus 1. That's our equation for our line in point slope form. As both the positive and the negative slope. Question, Aline? Nope. Shaking me off. D. Weiland. Yeah, the rise of the box is 6. From the center. Like when we construct the box. You know what I mean? You're right, the box is 12 units, but I'm just, okay. All right, the foci, what, last piece I got to do here. Foci, how do I find them? A squared plus B squared is C squared. So I got A squared is 36, B squared is 4. Add them together, you get 40. So therefore, C squared is equal to 40. So C is equal to 2 roots of 10. Let's see, root of 10 is what, like 3.1? So C is going to be like 6.2. So you can see the box was stretched 6 units in each direction. So the foci here are sitting 6.2 units in each direction. Just going to set them there really close to the vertices. So the location is going to be, what's the x value of our location for the foci? What is the 1, and then the y value will be negative 2 plus or minus those 2 roots of 10. So we added 2 roots of 10, and we subtracted 2 roots of 10. That's the location of our foci. One is the x value. And then from negative 2, because it's our center, we move up 6 roots, or up 2 roots of 10 and down 2 roots of 10. Better? Okay, so obviously I told you guys we're not going to do those just to save time. We got through that. We just did 2 examples instead of 4. Try to cut down. I think hopefully we're good to go. So here you go. Here's an assignment for you, which I know is what you guys were hoping for. Whoa, look at that. Where'd you go? Oh, if I can't find it. Way to take one for the team, buddy. Let's see. Homework cover sheets. Here it is. All right, 9.3, page 751, numbers 5 through 9, and 9.4, page 760, numbers 9 through 11. That is currently uploaded online. It is ready to be viewed for you. Okay? Do not fall behind in your homework. You want to start off on a good note. I promise you there are other tests during this unit that are super nice and easy, and you guys will do wonderful. These first 2 tests, you want to knock them out of the park because they can be a little bit more challenging. Okay? So. And if you're gone the past 2 or 3 days, videos are posted online. You can check it out there. I won't be available after school today. Tomorrow we got meetings for teachers, so not available then. If you want to come see me in the morning, I'll try to come on in. Tell my daughter to walk to orchestra practice. There you go. And 6th hour, I missed you. But fortunately, you have Mr. Durbin right there. He's a good dude. He begged me to sub for your class. He said you're his favorites.